Okay, so here's an example, and this is from 8.4 in our textbook, from our mathematical concepts textbook. And this is more about annuities, so a little bit different than the compound interest problems we've been doing. Rather than something where interest is converted from interest to principal and starts earning more interest, that's still happening in an annuity. But rather than just putting all the money in at the beginning and letting that money grow over time, this is a case where we put in money with each compounding period. So not only is additional interest being generated and converted into new principal, we are infusing the investment with new principal at each investment period, at each compounding period. So it's a slightly different concept than compound interest. It still has compound interest in there, but we're also adding to the investment. We're adding to the principal by increasing the investment every period as well. So the formula that governs annuities, it's a future value, and it's my investment, my periodic investment, and that's times 1 plus my periodic rate, my rate divided by the number of periods, raised to the number of periods, n number of divisions per year times the number of years, time in years, minus 1. And that's all divided by my periodic rate, r divided by n. Okay, so I pretty clearly, in order to be able to calculate A, which is ironically part A, is just the future value, right? How much will the company have in a scholarship fund for these children at the end of 10 years? And so they're investing $15,000. That's my P, right? And so we might as well write out over here, what are these values? P is 15,000. That's my periodic investment. And then every 3 months. Every 3 months is 4 times a year. And my interest is compounded quarterly. Both of those combine to tell me that n equals 4. Okay, then my rate, my yearly rate, because I told you that all these rates are going to be yearly rates unless we tell you otherwise, is 9%. And so that's why we're taking this yearly rate and dividing it by 4 to turn it into a quarterly rate. And that's what the R over N is actually doing for us. Okay, well, that's almost all we need. Last thing we need is the time in years, and that's given to us in part A of the problem. That's 10 years. So T equals 10 years. So let's assemble this. So A equals, and I've got 15,000 is my quarterly payment. 1 plus, and then my rate is 9%, but remember I always convert those rates over to ratios. So 9% becomes 0.09, and then that's divided by 4 because it's a quarterly compounding period raised to the number of compounding periods times the number of years to give me the total number of periods. Minus 1. That's all divided by my quarterly rate. All right. Well, that looks like it's going to give us the answer for A, but we still have to type all that accurately into the calculator to get it out. The real tricks, the real places that we could mess up typing into a calculator, the easiest ways to mess up would be getting these parentheses wrong, messing up that exponent, and then not getting this whole thing in the denominator. So I'm being very careful when I type this in to make sure that I get those things right. So I have 15,000, and then that's going to be times, and I have 2 sets of parentheses there, so I'm just going to start my 2 sets of parentheses. 1 plus 0.09 divided by 4. And then that whole thing, so I go outside of that set of parentheses, that whole thing is raised to the, and if you've got an older calculator, a TI-84 Plus will do this and give you that nice little box in the upper right-hand corner. But if you've got an older calculator, that little caret that I hit will just give you the caret symbol, and you'll have to use open close parentheses to make sure that all of this stays up there in the exponent. Otherwise, it'll just be raised to the 4, and it'll multiply everything by 10. So make sure that if you have an older calculator and it doesn't do this pretty print thing where it puts everything up in the exponent like that you have parentheses around that 4 times 10. And then we go minus 1. And that's my entire numerator. And so I go divide. Now I got to make sure that this entire thing from the denominator stays in the denominator. So I'm going to put parentheses around my whole denominator. And I'm going to have 0.09 divided by 4 and hit enter. And that's going to give me a total of $956,792. I'm going to round that to $93 because we're talking about sums of money here where pennies don't seem to impact our calculations as much. Okay. That seems like a pretty good value. Now the question is, what are the earnings of this investment? What does that mean? That means how much, well, interest did it earn, right? Because we want to find out what's the difference between the money we put into it, how much money did the company actually have to put into it, and then how much extra money was earned by the investment. And so there is a difference. Since we put in chunks of $15,000, we would expect this to be a pretty round number for the amount of money that we put in. And so what we should do is we should find out how much money we put in, and then take a look at this future value, and then find the difference between the two. And so to find how much money we put in, let's think of that, we'll call it P sub I for principal that we invested. And how am I going to calculate that? Well, I'm going to take that $15,000, which was how much I put in every quarter, and I put that in every quarter for 10 years. So I put that in a total of 40 times. I put that in 4 times a year for 10 years, which is a total of 40 times. And so that will tell me how much I actually invested. So I actually invested $15,000 times 4 times 10 will give me $600,000 of the company's money that went into this. And so that would make our earnings, that $956,793 minus my $600,000. And so my actual earnings are 956,793 minus my 600,000. That's going to give me 356, and we should be able to do that in our heads too. But it's always nice when you can do both ways and get the same number. It's comforting when you come to the same conclusion from 2 different directions. It helps you feel a little bit better about your result. 356,793. And so we found out part B is that we earned, so the future value equaling that was the answer to part A. And the actual earnings, the actual interest earned by the annuity is what we found there in part B, the difference between what we invested and what we got back out. All right, hope that helps us work these problems.